Welcome back to another video. Yesterday we went over the foundation skill of solving linear equations and inequalities. Today we're going to be going over the medium. So this is a bit of a step up from last time. No more one-step equations or inequalities. We're going to be having to do multiple steps in order to isolate our variable. So last video is really good foundations or introduction to this one, so I recommend that you guys go look at that one before watching this one if you feel like you still need some help on this skill. But we're going to do the medium today, and then tomorrow we're going to be going over the advanced version of this skill. We'll be going skill by skill, foundations, medium, and then advanced. So let's get started. Here we have two steps. We have our k as our variable here. Then we're adding on 3 and we are equal to 14. So just as I said last video, we need to isolate or get our k by itself. How we're going to do this? First step, we need to get rid of anything that's adding or subtracting. So we can see that k is being divided by 4 here, but we should move over our 3 before doing that. Addition and subtraction, we should move over first. So our first step is to subtract 3 from each side. Cancels out on our left side, and now on our right side, 14 minus 3 is 11. So we are left with k over 4 equals 11. Now we have that single step. If k is being divided by 4, then in order to get rid of the 4, we need to do the inverse operation of multiplication. So we multiply each side by 4. 11 times 4 is 44. We are left with our answer, k equals 44. Very similar to last time, we can also plug in our answer to double check. So let's do that here. Once we substitute in k equals 44 into our equation for k, we have 44 over 4 plus 3 equals 14. Go over this step by step. 44 divided by 4 is 11. 11 plus 3 is 14. So our answer of 44 is the value of k. On to our next question here. This one is quite difficult, but it's still the same concept. We need to treat, if we're trying to find the value of an expression or variable, so it could be x or x minus y in this case as an expression. Same concept here. We need to know to isolate not just a variable, we need to isolate this expression. So this time we need to get x minus y by itself. We can even treat it as a variable. If you wanted to, you could set x minus y equal to z and then solve for z. Here, I'm just going to get x minus y by itself. So first step here, addition or subtraction. We need to move over this positive 4, so we subtract 4 from each side as our first step. We are left with 5x minus y equals 3. Now, can we see that we have the 5 that's multiplying with our x minus y? So to get rid of the x minus y, we just need to divide by 5 on both sides. Cancels out. We are left with x minus y equals 3/5. So 3/5 is our answer here. If you wanted to, you could substitute in 3/5 back for the whole expression, and then you would solve through and get 3 plus 4, and 3 plus 4 is, of course, 7. So our answer for this one is answer choice C. Okay, moving on to an inequality. Of course, the skill is both equations, equal sign, and inequalities with our different inequalities. So here we need to get the x by itself. How we do that? Well, we move over addition or subtraction first. We have minus 3. To get rid of that, we add 3 to each side. So 7 plus 3 cancels out on this side. 7 plus 3 is 10. We are left with 10 is greater than 2x. Then we get the x by itself. We have a 2 that's multiplying with the x. So to get the x by itself, we divide both sides by 2. We are left with 5 is greater than x. So something really important to notice is that all these answers have the variable going first. Our answer has a number going first. So we need to switch places here. With inequalities, we might have to switch some things around. So very important. In order to get our variable over to our left side, we need to switch our sign. This narrow part of the arrow here should still be pointing towards the x. So when we put variable first, the sign actually changes from a 5 is greater than x to an x is less than 5. This format is something that you'll see quite a bit along with our negative signs, and that's what makes our inequalities unique. With our equations, 5 equals x and x equals 5 are the exact same thing. But inequalities, we need to remember that they have direction, and that is important to maintain. So when we go from number first to variable first, our sign needs to switch. So our answer here is x is less than 5. On to our last question here, another equation. This time we're dealing with some fractions. So fractions just go a little bit slower. It may take a little bit longer, but it is the exact same concept. Use what you know about adding or subtracting fractions, maybe even multiplying or dividing with that keep, change, flip. Let's see what we get through in this question. So we have a 1/5 here as a constant. This is a positive 1/5 because there's no negative sign, of course. In order to move it over, what's the opposite of a positive? A negative. We subtract 1/5 from each side. So it cancels out on our left side. Now we do 1/3 minus 1/5. Fractions, you're usually going to have to rewrite this off to the side. So this is what I like to do. 1/3 minus 1/5. With fraction subtraction, we need our least common denominator. So I haven't gone over this skill yet, but the basic things we need to do, we need to list multiples of our 3, multiples of 5, and the lowest one that matches is the one we need to pick. So 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 3 times 1 is 3, 3 times 2 is 6, times 3 is 9, times 4 is 12, and then times 5 is 15. We have our least common denominator being 15. So as we notice, we needed to multiply the 5 times 3 to get 15, and then we need to do that to the numerator as well. We needed to multiply the 3 times 5 to get 15. So we multiply our first fraction by 5 and our second fraction by 3 using our least common denominator method. And now we need to actually apply that before we can combine the numerators. So 1 times 5 is 5, and then denominator is going to be 15, of course, minus 3 over 15. When we subtract, denominators stay the same, so the denominator is 15, and then we just subtract the values in the numerator. 5 minus 3 is 2. So we have 2 over 15, and that's equal to 4h. So let me just rewrite here. 4h equals 2 over 15. And then same concept here. 4h, that 4 is multiplying with the h. In order to get rid of multiplication, we need to divide. So we divide each side by 4, and then we get the variable by itself, but we have a compound fraction here. Whenever we have two division bars, we have a compound fraction. What we need to do here is to convert this vertical notation into the horizontal notation of division. So this big bar right here, it turns into a horizontal division sign. You probably remember this from 4th or 5th grade. But that is very important here. So now we rewrite 2 over 15 divided by 4 over 1. And then here we can apply keep, change, flip. We keep the first fraction the same. We change the division sign to a multiplication sign. And then we find the reciprocal, or we flip 4 over 1 to 1/4. Then we just have fraction multiplication, and we can just go horizontally wise. Unless we want to cross reduce here, which I recommend. 2 and 4, they share 2 as a factor, so we can just divide 2 out. We get 1, we get 2. Now we can multiply. 1 times 1 is 1. 15 times 2 is 30. So our answer here is 1 over 30. So the value of A is 1 over 30. We put it in the improper form. Usually they don't want mixed numbers, or else you're going to mess up the formatting on the SAT. So definitely keep as improper fraction or a proper fraction in this case, when the numerator is less than the denominator. So we got all answers correct here. I hope this helped. Tomorrow we'll be going over our advanced. Make sure to subscribe for these daily videos of going over these SAT digital math skills. And I'll see everyone in another video. Goodbye.